Let's use the pre-flight central box example panel to show some techniques for putting telemetry values or Lua expressions made of telemetry values into text boxes, and maybe a little bit of what this panel is designed for. So the idea here is to have a panel that you'd probably set as your home panel, so that when you turn the transmitter on, if this app is loaded, this panel will come up, and this would be designed for an airplane with a Jetty, any of the Jetty central boxes in it that would have two batteries, and it would show you the voltage and the current draw of the two batteries. It could show you some things like your receiver voltage. It could show you the state of your turbine if it's a turbine-powered airplane by reading the turbine ECU. And it could show you some information about the state of the battery pack. And then we do have the ability on the gauges to put little tick marks on them for the maximum and minimum values that they've seen. And so we could, for example, after we powered the plane on, stir the sticks around a little bit to move all the controls through their full range of motion, and see if we get any current spikes, and that would get recorded by the little bug on the outside of the gauge showing you that you maybe had a binding control. So that was kind of the idea. I mean, this panel was made up obviously as an example for how to build a panel like this, but those are some of the reasons that it might be a plausible thing to have on startup. So let's start with the app, and we're running the app in the Jetty transmitter emulator on a computer. So it's a convenient way to make videos. And you can see under user applications, I have the instrument panel app, and I also have my sensor emulator app. So it's an app that runs alongside the instrument panel that pretends to be a bunch of sensors, because obviously the virtual transmitter doesn't have any sensors. So let's go into our instrument panel, and let's go up to panels, and let's read in the pre-flight C-box panel. We'll give it the nice carbon fiber hexagon background. And we'll jump up to the top here, and you can see there's our blank panel without any of the telemetry inputs connected to it. So first, let's turn our attention to the inputs, and let's, for RX1 voltage, that'll be a sensor. You notice here you can have the input for one of these widgets, meaning a text box or a gauge or whatever generically called a widget. It can be a telemetry sensor, one of the controls on the transmitter like a switch or one of the sticks or a logical switch, or it can be a Lua expression, a mathematical expression that I could put in. So this is going to be a sensor, and the RX1 voltage is going to come from what Jetty calls the transmitter telemetry. So this is the kind of the base telemetry that the transmitter has, and so we picked TXTEL RX1 voltage for that. And then the second thing we'll look at is this sequence text box for the turbine status, and that's also going to be a sensor, and my sensor emulator has a little counter in it that goes 1, 2, 3, 4, 5, 6 as I throw a switch, so we'll set that. We also have the ability in general to have a function extension, a Lua function extension that operates on the sensor data before it passes it along. And so in this case, I'm gonna use a Lua extension. You see that the only one that's in here is for the Zikoi Telemetry X adapter, and it turns that sequence number into some text. And so I know from Gaspar's website what all the codes are that the controller can give, and I know what the text messages that would be on the hand data terminal, so we reproduce that. And that's written as a piece of Lua code. It's just a short, few line piece of Lua code that you can write actually instances of yourself if you want to. I've written this one as an example. Okay, so now let's go to battery number 1, sensor, and we have the emulation for battery 1. And let's turn on the min-max for that, and then we'll go to sensor and battery 2, turn on the min-max for that. The current, also a sensor, number 1, and we'll turn on the min-max for that. Battery 2 milliamps, another sensor, and do that, and the min-max for that. Okay, and then back up to the top, and so what you can see now is that we've animated the gauges. So slider number 1 is going to be the the battery voltage number 1, slider 2, battery voltage number 2, and you can see the little min-max markers moving. Slider number 3, controlling my battery 1 current, and slider number 4, controlling my battery number 2 current. All right, so we've got the gauges animated, and if I cycle through the turbine sequencer, you can see it's going through some of the codes for the Zikoi turbine. All right, very good. Now let's turn our attention to that 4-line text box. The way that we put these variables into the strings, you saw that on the RX1 voltage where it said quote V quote quote U quote single quotes. This technique of putting a number or a variable into a string, programmers refer to that as string interpolation. And a lot of the different computer languages have some very nice ways of doing that using special characters, curly braces and things. But we had to do something here that only used characters available in the Lua text editor that lets you edit text on the transmitter. And it really doesn't have all those fancy characters. In fact, one of the only things we could use was the single quote. So you'll see that the quote V, when I set the value of that top widget, the RX1 voltage text widget, to be RX1 volt, TXTEL RX1 voltage, it plugged in where it was quote V quote, it plugged in that 0.0, because again, this is the emulator. It doesn't have an RX1 voltage, but on your actual radio, it would fill in the receiver voltage. And then quote U quote would be the units that went with that telemetry channel. So in that case, it would be volts. Set idle is coming from the Zikoi Lua function extension for the turbine, but again, you could write your own, do anything you want with the Lua values. And again, the reason we did it is you can't really express that mapping of numbers to strings in a simple way without writing a program. Okay, and then on the bottom box, we wanted to learn something about the battery status. So you see that quote S1.2V S5.0%. So the S1 is what I call a Lua variable. So it's a variable, but it's tracking the value of some telemetry channel. And I'm going to show you in a moment how to set that up. And the 0.2 means that's 2 decimal places. Since it's a computed expression, we don't have a unit for it, so I just put in the V for volts by hand. And then I'm going to show you S5 is what is going to be derived from a Lua expression, so a mathematical expression derived from the battery voltage and a special function, okay? And that's going to be in percent, okay? And then the battery 1 capacity, battery 2 capacity are telemetry channels that come directly from the central box. So let's dive into that. So go down to Applications and the instrument panel and the Lua variables. And so there are no Lua variables right now. So let's say plus, let's add one. So it'll just start out with S1. In fact, let's go ahead and create up to S8. Okay, so let's go up to the top here, S1. So we want S1 to be the voltage of battery 1. So we know what that is because we already set a gauge to that value. So that's the central box voltage 1. And then S2 is a sensor, and we want that to be central box battery voltage 2. And then S7, we want to be the capacity, or what Jetty calls capacity, capacity 1. And then S8 is going to be, let's try to go from the bottom here, capacity 2. So let's go back up to the top and see what that looks like. Okay, now we see that we're filling in 6.68. So you see that agrees with the rounding on the gauge. If we move slider number 1, you'll see that the gauge moves and the value moves. We still haven't filled in S5 and S6, but you can see that sliders number 1 and slider number 2 are moving the gauge and that value on the screen. So that's great. And then battery 1 capacity and battery 2 capacity, I have my sensor emulator program running along with the instrument panel program, and so I'm simulating the sensors from a central box. And so these sliders 5 and 6 are, as you run your central box, and the battery starts drawing current, it will start increasing. So if you think about it, the central box doesn't know the capacity of the battery. The central box does know how much current is being drawn, and it knows how to integrate that over time. So the central box knows how much capacity in milliamp hours that it's burned up. So it really has to only report what it's consumed. It doesn't know how much is left because there's no way the central box knows how big a battery is connected to it. Now you know that. So if you wanted to write a Lua expression instead of just connecting to the sensor, and you knew you had a 5,000 milliamp battery, you could create, this variable like we just did, this S7 variable that's plugged into battery capacity 1, and then instead of S7, you could put in another Lua variable, maybe you could call it S9, that would be a Lua expression, which would be 5,000 minus S7, and you could plug that in to this spot instead of S7, and then it would read the capacity remaining from the battery pack, because you know the capacity of the battery pack, but of course the central box doesn't. But we'll just leave it at the standard Jetty style for right now, and you can see capacity 1 and capacity 2. I can simulate that. All right. Now let's turn our attention to S5. So we're interested in the state of charge, right? What percentage of charge is left? Now, it's very difficult, especially with LiFe's, because they have a very flat discharge curve, and ideally the battery should sit for a little while to equilibrate before you take this reading. But I did go out and did some research and found some discharge curves for LiFe and LiPo batteries, and so I wrote them as little Lua programs, little short Lua programs. And by the way, you can add your own. These are extensions that will actually show up then as functions within the Lua expression editor. I'm going to show you that in a minute. So if you want to add your own numerical functions that show up within Lua expressions, you can do that too. Okay, so let's go back to Lua variables, and let's go to S5. And S5 is not going to be a sensor. It's not going to be a transmitter control like a stick or a switch or a logical switch. It's going to be a Lua expression. Okay, and so let's go into that Lua expression, and these functions that I provided in this extension are going to show up here as LiFe S, which is the capacity of a LiFe battery as a function of its voltage, and LiFe V, which is the LiFe voltage as a function of its state of charge. So the one that we want for this purpose is LiFe S. Excuse me, hit the wrong button there. Go back to editing our Lua expression. So we want LiFe S, and then we want an open parentheses because we're calling a function. Okay. Now LiFe S is the equation, the discharge curve for one LiFe battery. So S1 is the voltage of the pack, which is in a LiFe, it would be 2 batteries. So we're going to say overshot a little, S1, that's 2 batteries. So we're going to say S1 divided by 2, close parentheses. And then it'll give you once it becomes a valid expression, it will give you the number there. And so let's go back to the top and see what we see. So we see at 6.46 volts on battery 1, we're at 27%. So we're right at the junction of the yellow and the red. And of course, you can change the boundaries of the yellow and the red and the yellow to the green as you see fit. But it's reading 27% state of charge. Okay, so it'd be a little low. I wouldn't fly with that. You probably wouldn't either. But of course, since we're sitting in an emulator, we can pump that up to the green, and we're sitting there at 98% at 7 volts. Okay, and we can do the same thing for S6. S6 Lua, and then we edit the Lua expression, and then this would be LiFe S, open parentheses. In this case, it would be S2 divided by 2, close parentheses, 97%, okay. back up to the top. And so now we see 97%, slider number 2, bring that down, bring it right into the red there, sitting at 9%. Okay, so now we've animated everything on this panel. We've got the receiver voltage coming from the transmitter telemetry. And since we only have one value, we've associated that telemetry channel with the widget, the RX1 voltage text widget, and we just included it's built in as quote V quote. Okay, don't need any Lua variables for that. You could, but it's just a convenience. On the turbine status, it's a sequenced text box, and so it reads a variable. And then from that variable, it sends it out to an external function. The Zcoid telemetry function brings it back and displays a string. And then in the four-way text box, we've used a bunch of Lua variables to show how we can use some of the Lua capabilities and how we can add our own extended functions that we can code in Lua. And actually, they're not really part of the app. They get loaded in as modules when the app starts. So you're free to add your own versions of functions like I did for LiFi and for LiPo. In fact, you may not like the discharge tables that I picked. You might want to put in different ones, but it gives you a lot of flexibility of doing some fairly fancy manipulations with Lua, extending Lua with your own functions, and then displaying things on the screen either graphically with the gauges or with the text. And it gives you the little ticky marks here so that as I stir the sticks and watch the current being drawn as the control surfaces on the airplane move, I can see where the high watermark for current and maybe the low watermark for voltage ended up, and give me an idea if I've got all my controls free and clear and I'm ready to fly.